Hello, this is a final continuation of session 15, beginning with number 65. Remember that we were looking at the areas for the inequality that might work. So what we're going to do here is, since we have a fraction, we're going to set each of these equal to 0, the numerator and denominator. The important feature is do not multiply by x squared on both sides. You're going to lose a root that way. Make sure that everything is on one side equal to 0, in this case less than or equal to 0. And then after that, proceed to take the numerator and denominator, set each of those equal to 0. So we're going to say that 4 minus 2x equals to 0, and also that x squared equals 0. Now for the numerator there, if you subtract 4 from both, numerator, subtract 4 from both sides, you get negative 2x equals to negative 4. Subtract 4 from both sides. And then proceed to divide by negative 2. Divided by negative 2, x equals 2. So we have one key number, or one critical point here, x equals 2. The next one, x squared equals 0, obviously you take the square root of both sides, and x equals 0. So we have 2 points considered, x equal to 2 and x equal to 0. We're going to put that on a number line. And we're going to test each of the areas. Let's test the area maybe to the left of 0. Negative 1, negative 2, whatever you'd like to choose there. I'm obviously going to choose the negative 10 as I like to. Negative 10 there. Replace the negative 10 back in the numerator. Erase this x equal to 0, x here and x here, and in place of that put a 10 in both cases. In fact, negative 10. The numerator, we're looking at 4 minus 2 times the negative 10. That's 4 plus 20, 24 in the numerator. Really not terribly necessary to worry about the number. The fact is it's a positive 24, isn't it? Positive 24 there. And the denominator, negative 10 squared, 100, that's also a positive. Again, not too terribly concerned with the numbers. If you look at that as positive divided by positive, that's a positive number, not less than or equal to 0. Negative 10 doesn't work. Let's try here between 0 and 2. Of course, a good choice between 0 and 2. How about 1? You're choosing 1 there. Again, go back, replace the x with a 1. Let's see what happens there, okay? The numerator, we're looking at 4 minus 2. 4 minus 2 is 2. That's a positive number. And the denominator, again, always positive anyhow because we're squaring that. How about the same thing? A positive divided by positive is not less than or equal to 0. We're going to go ahead and then say, look, that doesn't work either, so we'll exclude that. The last area to check is maybe greater than 2. You could try 5, 3, 4, any of those numbers. I again like 10. 10 is an easier number to square and multiply by. So let's choose 10 on that. Again, replacing 10 back here in the numerator, we're looking at 4 minus 2 times 10. 4 minus 2 times 10 is a negative 16, 4 minus 20 if you would, negative 16. We're looking at a negative up top side here. And then of course in the denominator it's always positive because we're squaring that. That looks like it's less than 0, doesn't it? And negative divided by positive is negative. So it looks as if we have a good answer for us here. It looks like maybe this answer right here, anything greater than 2 should work very nicely for us. Okay? We're going to say, okay, how do we represent that? Well, just as I said, anything greater than 2. How about x is greater than or equal to 2 on that? I go back and check to see, remember we have an x here in denominator. Make sure that when you replace the x with a 2, it doesn't give you division by 0. Since that isn't the case, then we'll say, okay, that's all right, that's great. 2 will also work. We want to make sure that if we put a 2 up top here, 4 minus 2 times 2, 4 minus 4 is 0. That's no problem for us, but denominator 0 would be a problem. And we're going to use 2 there in our denominator. 2 squared is 4, that's no problem for us at all. Good answer then. We have x greater than or equal to 2. That's our answer for number 65. Now that finishes page 378 for us. The next page, page 388. We're going to look at page 388 and see what happens on that. Page 388, and maybe you have to read that a bit because it's the word type problem. And I think I was going to work with you there, number 11. Number 11 on page 388. Number 11 says that the circumference C of a circle varies directly as its radius. What we like to do is to set up an equation based upon that. And before we can do that, we have to know something about direct and indirect variations. So I need to go through that with you very quickly. Taking a look at something like this, xy equals to k, we'll try some numbers in there. I'm using k as 12. K is our constant, and nice to use 12. It has many factors there. It's a small number, so nice to play with. Let's see what happens on that, okay? Let's try maybe x as 1, 2, 3, and 4. If x is 1, 2, 3, and 4, what will y be? Well, we need 1 times some number to give us 12. 1 times 12 would work very nicely there. And we need 2 times something, maybe 2 times 6, and 3 times 4, and 4 times 3. Let's take a look at what's happening, okay? As we talk about x, as x goes down, 1, 2, 3, 4, it's increasing, isn't it? It's increasing as it's going down. How about y? As y goes from 12 to 6 to 4 to 3, it's decreasing, isn't it? When 1 is, we can do the same thing with the other way. We can talk about the bottom, 4, 3, 2, 1. As we go from bottom to top, the x's are decreasing. As we go on the green from bottom to top with the y's, 3, 4, 6, 12, the y's are increasing. When one is increasing as the other is decreasing, we call this indirect or inverse variation. So looking at xy equal to k, we're going to say this is indirect or inverse variation. Let's look at the other option for us. This is x over y equals to k. And we'll try the same thing. Again, using 12 because 12 is a nice easy number to play with. We'll just try a few examples on this one. Let's let maybe x here be 48, and then 36, and then 24, okay? So looking at the top one here, if x is 48, what number do we have to divide 48 by to get 12? That's obviously a 4 there. Here 36 is x, what we need for y to get 12, how about a 3? And then lastly 24 for x, we need to divide by 2 to get that to be 12. Let's see what's happening with the green and the red here, or with the x and the y's. The x, 48, 36, 24, looks as if we're going down on that, getting smaller there. As we start at the top here, 4, 3, and 2, also getting smaller, aren't we? So as we go down, as the x's get smaller, the y's also get smaller. This is called direct variation. If we go up, 2, 3, 4, x's are increasing, and also 24, 36, 48 also increasing. So we have both of those x and y's are increasing when going upwards or downwards. We call this direct variation. So looking at x over y equals to k, we're going to call that direct variation. So these are our two variations. Sometimes the author will say joint variation. That means direct variation, and then we're going to add some other maybe items to that. We'll see as we talk about that for some of the other problems. So going back to number 11 now. 11 says that the circumference C of a circle varies directly. So we have to choose which one to look at. We're going to talk about here the x over y equals to k for that one. So let's proceed to write that formula down for us. X over y equals k. And then we'll proceed from there to insert the values. There's page 388, number 11, and we're talking about C varying directly as R. So C varying directly as R, something like this. And we're going to call that equal to K. Okay, C varies directly as R. And then what the author doesn't say really is to solve for that first letter, solve for C, multiply both sides by R, and we'll look at this. C is equal to RK or KR. Okay? That should be what we're looking at for number 11. C is equal to RK. After that, proceeding to number 19. 19 is a bit more involved, but we'll try to read it first quickly to get a general understanding of what we're talking about, and then after that we'll go a little bit slower and try to fill in the blanks. For number 19, the variable C varies jointly as m and n and inversely as the cube of t. Reading it one more time. Now you read it once first to get a general idea. We're talking about variations here, either direct variation or indirect variation. In this case, we'll look at 19 as the variable C varies jointly as m and n. That's going to be a joint or a direct variation. So we're going to go back to same thing as number 11, and C will vary jointly as at this time m and n. And it also varies, as we're told, it varies, that's direct variation, it varies inversely as the cube of t. Now inverse variation is here xy equals to k. So if it's inversely as the cube of t, we'll use a t cubed here next to the c, and that should all equal to k for us. So we're talking about the c varying jointly, or in this case directly, as m and n. That's c divided by mn. And also inversely or indirectly as t cubed. Then we use the t cubed there in the numerator, the same as the xy equals k. To solve this one for C, we like to eliminate the t cubed and the mn. Basically just do the reverse operations on that. In other words, ct cubed over mn is equal to k. How about on either side, how about the left side here, maybe multiplying by mn and dividing that by t cubed? How about mn and t cubed here? And the same thing, of course, on the right. Let's go ahead and multiply by mn and divide by t cubed. On the left side, the mn's will be eliminated, and so will the t cubes. We're left with c. On the right side, we have an answer for us. That's equal to k mn all over t cubed. There's an option of how you want to represent that, whether you want to go ahead and just put k first and alphabetically with the letters, or any other way. It doesn't make any difference. Should be a good answer for us there for number 19. Maybe two others for us there. Excuse, one other for us. Number 31. 31 has a few parts to it. 31, reading that very quickly, it says that a rental car company charges a fixed amount of rent to rent a car per day. Therefore, the cost per mile of rent to rent a car for a given day inversely proportional to the number of miles driven. If 100 miles is driven, the average daily cost is 80 cents a mile. First A, to determine the cost for 200 miles, and then B, the cost for 300, C, the cost for 400, and D, a little bit different situation, that if we have the cost of 16 cents a mile, in fact, how many miles have we driven there? So let's go back and let's try to understand what we're talking about here, and then once we get the proportion set up, then we'll proceed to take a look at how to insert the data. Information not coming off the board too well today. Second reading. The rental car company has indicates that the cost per mile for renting a car for a given day is inversely proportional to the number of miles driven. So I'm going to use C for cost and M for miles. And we're going to say the cost is inversely proportional. Remember, the inverse proportion is multiplication situation there. Maybe CM on both of those. And then we're told that in the next situation that if we drive 100 miles, it's going to cost us 80 cents a mile. So the cost here, 80 cents a mile, 0.80. 0.80 times the miles, 100 miles. And the question is, what would the cost then be per mile for if we're going for 200 miles? We'll use the C here, and then the mileage is going to be 200. So we'll put a 200 there. And then of course, very simply, just a matter of solving for C, and we're basically finished on this. How about dividing both sides by 200? And the 100 and 200, the zeros will both go. And basically we're looking at dividing 2 into 80. When you divide 2 into 80, that sounds like 40 cents here. So it looks like 40 cents a mile for this. 40 cents per mile is the cost that we're looking at if we drive 200 miles. And we'll do the same thing for the next one. This is part A. Part B says, what happens if in fact you drove 300 miles? Okay, we don't really have to set up the same thing again. You can see what's going to happen for us. We're going to have 80 cents per mile here for 100. That's not going to change. What's going to change is our 200. Instead of our 200, we'll have 300 here. And then it's a matter of proceeding to say, okay, let's go ahead and do the same thing we did with the previous one. Let's go ahead and eliminate the zeros here. And how about 3 into 80? 3 into 80, I'm thinking goes maybe twice there with the 6 in the 0.2 there, and that's 6 and 20 again, maybe 6 on that. And it looks like we're going to be recurring with the 6. How about 27 cents, okay? 27 cents. So for part B, it's 27 cents. And then, let's see if I can maybe squeeze